Today we're going to be talking about the law of sines. Okay, chapter 5, section 6. Hopefully you have this right here, the law of sines, in your journal. And we're going to go ahead and zoom in on problem number 1. Okay? Now, one thing that you'll notice about the law of sines is it's not restricted to simply right triangles. You're allowed to use it with acute triangles and obtuse triangles. Now, there are some cases where you're not allowed to use it. We'll learn about those cases later. Today, we're just going to learn about how to use it. So the first thing I want you to do is I want us to create a box that represents all of our answers, because when it says solve each triangle, what's that asking you to solve for? Every single side and every single angle. All right, so we're going to list out what we have and what we need. All the lowercase letters represent what? They all represent sides, and all the capital letters represent angles. All right, so we have angle A, that's easy, 38, got that. Angle B, that was given to us, that's 63. What we've been used to doing is angle C has always been 90, right? Because we're working at right angle. Well, that's not the case anymore. We got to take these two guys and take them away from 180. 79 degrees. So these all have to add up to what? 180. You guys notice that this triangle is definitely not a right triangle? Right? This would be considered to be, and no, it's not isosceles. It's an acute scalene triangle. The word scalene means they're all different sides and all different angles. Acute means every single one of these angles is going to be less than 90. Okay? And so far we only have one side. It's 15 units. We don't know if it's feet, miles, inches, whatever. It's just 15 units. So what are we looking for? We're looking for the length of side A. We're looking for the length of side B. So I'm going to draw a little picture of a triangle that kind of represents this as best as I can. So the first angle I'm going to make is about a 79 degree angle. All right. So I'm going to make our triangle. So that's 90. So I'm going to go just back a little bit. I'm going to call that 79. All right. I'll call this, let's see, 60 degrees, somewhere right in there. All right. I'm just estimating right now. Okay. So I'm going to call this the 63 degree angle. I'll call this our 79 degree angle, and the last angle was our 38 degree angle. We're going to call this capital A. We're going to call this capital B. And this one right here, I'm going to call capital C. I'm going to label this lowercase c with 15. Call this lowercase a. Call this lowercase b. You'll notice that the sides are always what? They're always across from your angle. Lowercase b is across from angle b. Lowercase c is across from angle c. And lowercase a is across from angle a. So I'm going to highlight it in different colors, all right? Go. Blue. All right, there we have. Now, we're going to set up two little proportions, okay? The first proportion that we're going to set up is going to help us solve for lowercase a. So I'm going to set up a proportion for lowercase a. So here's what I want you to do. I want you to write lowercase a over the sine of capital A equals lowercase c over the sine of capital C. So this is going to be the proportion that we're going to set up. Lowercase a over the sine of A equals lowercase c over the sine of C. Then we're going to plug in the information that we have. We don't have lowercase a, but we do have capital A. What is capital A equal to? So we're going to write 38. Just remember that 38 degrees represents the measure of the angle. Equals. We will, yeah, but we're not going to, we won't worry about the decimal just yet. Okay. All right, what is lowercase c equal to? 15. So we put 15 for lowercase c. And I'm going to put the sine of angle C. What's angle C equal to? 79. And in the graphing calculator, you don't have to put the little degree symbol. I'm just putting it right there so you understand that that's referring to the measure of the angle. All right, there's our first proportion. Now, that's not our final answer, but that's how you set the problem up. Okay? Yeah, we will cross multiply in a little bit. Okay? Right now, we're going to set things up. We'll cross multiply in just a second. Now, what I want you to do, just to the right of it, if you have room. If you don't have room, you can put it to the bottom, I guess. We're going to solve for lowercase b. And I think our lowercase b is in red, right? So I'm going to write our answers in red. I'm going to put lowercase b over the sine of capital B equals lowercase c over the sine of capital C. Now, you may be wondering why in both problems we're using c over the sine of c in both problems. The reason why I'm doing that is because that's the only information where I have both the angle and the side. So you always choose the one that has the angle and the side when you're setting them up. Okay? So over here on the right side, I'm going to still put a what? Still put a 15 and the sine of 79, but on the left side, I'm going to put b over the sine, and what's the measure of our angle b? 63, right? Let's put 63 degrees. Put the little degree symbol right there for the second. And this is your proportion set up to help you solve for side b. So let's look at what we have here. There's our triangle. Here's our first proportion. There's our second. What's similar about both of those? What are we using both times? Sine, you're right. But notice, see how we used c over sine of c both times, because that was the side and the angle that was given to us. All right, so now what we're going to do, everybody, is we're going to cross multiply. So I'm going to choose a different color right now. I'll use this orange color, maybe that's useful. We're going to cross multiply so you can still see through things. So what are the cross products right here? The cross products are going to be a times the sine of 79. So in your journal, what I'd like you to write is a times the sine of 79. That's the product between those two. What does that equal? That equals 15 times the sine of 38. A times the sine of 79, I put right here. 15 times the sine of 38, I put right there. So I'm going to rewrite that so you guys can see the cross products, because we have one more step that we're done. Now, what are we solving for? We are solving for A. That's what we're solving for. Which means, if I want to solve for A, what I'm going to have to do is I'm going to have to divide this side and divide this side by the sine of 79 degrees. Okay? So what happens to these? They cancel out. And A is going to equal whatever 15 times the sine of 38 degrees divided by the sine of 78 degrees. Just remember, what does this part right here represent? That part represents the cross products. That's what these represent. So what was our final step? We had to divide both sides by? We had to divide both sides by the sine of 78. So if you have your graphing calculators, right? Sorry, 70. So what you can do, hit alpha, y equals, enter. All right, and in the numerator, what are we going to type in the numerator? 15 sine what? 38. Close the parentheses. Down here, what are we going to type in? The sine of what? 79. Press enter. What do you get? 9.407. Just round it to the nearest tenth would be 9.4. Now, if you didn't want to use alpha y equals enter, you could also type it in this way. 15 sine 38. But you better close the parentheses. Watch. Gotta close the parentheses before I divide it by the sine of 79. And it gets the same answer. So if you like to do it horizontally, where you just do it that way, you can. Alright? But you can also use the alpha y equals button to get that little fraction mark. Okay? So right now, I'm going to go back, and for right here where it says A, I'm going to erase this, and I'm going to put in our answer of what? 9.4 units. And now what I'm going to do, everybody, is we're going to find the cross products for B. So I'm going to go over here. We're going to once again find the cross products for B. So I'm going to do this in red. B times the sine of 79 degrees is simply B sine 79. B times the sine of 79 equals, what's the cross product of 15 times the sine of 63? What am I going to write? 15 sine 63. And what does this right here represent? That's the cross products of the proportion. So I'm going to rewrite it before I divide. Hopefully you guys can see that we end up dividing by the exact same thing we did before. What am I going to divide both sides by to solve for this guy? What am I solving for? I'm solving for B. So what am I going to divide by? The sine of 69. 79, right? Sine of 7. So these cancel out, and our final answer for B will be whatever the approximate value is for 15 times the sine of 63 divided by the sine of 79. So we go to our graphic calculator. Watch what I'm going to do this time. Ready? I'm going to scroll up here. I'm going to grab that. Press enter. I'm going to change something though. What's the only thing I'm going to change? I'm going to change the 38 degrees to what? 63. Because if you think about it, let's go back real quick. What's the only difference between our two answers? This one has 15 sine of 38. Our other one has 15 sine of 63. So yeah, I'm just going to go right back here. Press enter. And there's my other answer, 13.6. So I'm going to take 13.6. Erase the Solari right here. I'm going to write in 13.6 units. And once again, remember, when I ask you to solve each triangle, what am I looking for? All three angles and all three sides. You can use the law of sines to find the missing sides and angles. We'll worry about angles later, but right now we're worried about finding missing sides of